Now let's use factoring to solve literal equations. Here's an example. Notice that we can't combine these terms because they're not like terms. At the same time, we can't really solve for a because there's two factors of a, and we need a single factor or a single term of a in order to solve for a. So we need a technique which allows us to go from two a's to one. Notice I'm trying to solve for the GCF in this situation. So if I factor out the a, I'll be left with a single a times the quantity b plus c, and then since there's a single operation happening to a, I can use a single inverse to undo that operation, and I've solved for a. I'm going to include the checks, and as you saw in the last video, some of the checks can get pretty involved. I'm not really expecting that you're going to have checks like that on a test or a quiz. But let me just go through this one to show you that you do have the tools to check your work. If we replace a with our expression, then I'm going to multiply b times this factor, which will just give me b over b plus c. I'm going to multiply c times 1, and I'll get c over b plus c. I have a common denominator. I can keep one copy of the common denominator, add the numerators. These are similar factors, that is, this is 1 times b plus c, and when I reduce, I'll get 1. Here's one for you to try. This time our GCF is k, so I'll factor that out. Then, once again, we have a single operation happening to k, so we can undo it using division, and we've solved for k. Here's the check. Now you may have noticed our last two examples, we only had terms with our variable of interest. Sometimes, though, you'll have other factors or terms, and so you'll have to use some algebra to get to the situation you're looking for. For instance here, since I'm solving for x sub 1, I'd rearrange the terms to get those two terms together. Then I'd factor out the x sub 1. And notice now I have two operations happening to my variable of interest. I have a multiplication and addition. Building a table, I can see I'll be using subtraction and division. I'll subtract first, I'll divide second, and I've solved for x1. Here's the check. Here's one for you. After rearranging my two a sub naught terms and factoring out a sub naught, I have a product and a difference. I can undo that using adding and dividing. I'll add first, I'll divide second. Here's my solution, and here's my check. And here's the last one. After rearranging my terms and factoring out my GCF, I have a product and a sum. I subtract and divide to undo those operations. Subtracting first and dividing second, I get this expression. And here's my check. It's a little involved. See if you can work your way through it, though. It's very interesting, at least to me, because right here we use factoring by grouping to move forward. Well, that will conclude this video where we used factoring to solve literal equations.